So let me start by thanking you all for joining us today. And I want to send special thanks to the College of Engineering for supporting my travel to this really interesting and impactful symposium in CS education. It was really a great experience joining the conference. Special thanks to you, John, and also to Brent for all the assessment during the registration process. Um, so yeah, sharing this experience, let me learn how to use this clicker. Yeah, the conference has many tracks. As you see in the slide, I included the link, but there is no time to open this link showing you the a huge number of papers that are running every day. The conference was on 4 days. Wednesday included many teaching faculty activities or professional development sessions for teaching faculty, and the conference used to run from 8 a.m. to 7 p.m. with so many parallel sessions, like you can find 10 parallel sessions at the same time. So it was really overwhelming to choose which sessions I will attend with this large program. But it will become much, much easier when they send us the WOVA app. Within the WOVA app, I was able to see the full agenda of the conference, which contains hundreds of sessions, I think more than 300 sessions in the conference. But the WOVA app made things easier, as I was able to see the full agenda, select sessions, add them to my personal agenda. And the app will also tell me if I have a conflict or I schedule to attend two things at the same time. So things went easier upon receiving the link to this app. My experience and observation, like too many topics, not all of them are listed here, but I focused on AI and teaching in the era of AI, teamwork and assessment, as my course include a team project, and I also mentor capstone projects with the College of Engineering. Um, Another interesting thing in this symposium, the too many formats to engage. So you don't have just to sit there and listen to presentations all the time. There were like tutorials, hands-on. These tutorials were scheduled after the conference hours from 7 to 10 p.m. And I was able to attend two interesting tutorials and impactful tutorials during my attendance. There were panels, keynote speeches, research paper presentations, of course, and the poster session, plus those special sessions, which they call the birds of a feather, where we have focused the group discussions, then the attendees will designate someone to present what the topic that they discuss. So it was like interesting experience with all of these various ways of interaction and engagement. Um, Let me go first over like 2, 3 of the research papers that I attended. The first is the capstone and team-based assessment. One paper focused on how do we assess individual work within teamwork, especially in capstone projects. And they introduced several ways as to evaluate students based on one thing is not enough. So we can combine several aspects to grade the individual contribution. One of those is the peer evaluations from their colleagues. We can also use or track their contributions to the GitHub repository. We can do meetings to follow up with the process, so we do not have to grade only the product, which is produced by the team. There should be several other ways to assess the individual work within these projects. Another session or research paper on capstone projects was about the effect of project type on capstone courses. And this paper was interesting as there was a study on how the project type, whether it is student choice project or an instructor assigned project, along with industry or real projects with real real industry or real client who assigns the project. And they compared the learning and career readiness of the students, also students' feedbacks on self-evaluation on their experience on those projects. It tends to be that their results, of course, is that working with a real client is better for both the student readiness for career as well as for assessment and getting feedback, as they are getting two feedbacks, one from the instructor or the mentor, which is academic feedback, and another from a real customer. Another research paper was the impact of AI on student learning, which was interesting. I liked it when the presenter went to say students are abusing AI. It's just the process of copying the answers and pasting them in their assignments, which will affect the student learning. So students feel like they improve their performance, they solve their assignments very quickly. Maybe they read the answer, they think they understand it, but actually there is no deep learning or long-term learning of what they get from AI. So it also focused on how programming and producing systems have changed. So as you see, these are pictures that I took from the slides. I'm not good in taking pictures. And sometimes maybe I needed to clean my camera. So as the slide says that today we have most of the time in solution and coding, less time in problem analysis and specification, along with debugging, validation, and so on. And the future is changing, where coding is no longer the bottleneck. Yeah, I see the future is running, by the way. So we are now in this future where students or programmers need less time in developing the code. There should be, the industry says this also in many sessions, like programmers should use AI to produce the code. The focus is not on producing code. AI can produce code. Industry needs people to critique this code, debug the code, find any issues or any design smells in this code. With that, the focus in the new or in the era of AI is in writing good problem specifications, how students can write the specifications, even if they will use their virtual assistant. So it's no longer that programmers are programming by themselves. They are having this robot next to them, which is the virtual assistant AI. And taking this into consideration, they need to know how to ask questions and how to do prompt engineering, which prompts they need to send to AI in order to get the correct answer. And to be able to do that, they need actually more skills. It is not only skills in writing the code. These are skills in problem analysis, defining the problem. They know, because if we were able to define the problem precisely with no ambiguity, AI can provide better code, and that will reduce the testing and correction time that we need. Also, more time for testing, validation, and figuring the design aspects. But this is also a higher skill than coding. If you want to validate a code that is already generated, it's harder than generating the code from scratch. Another research paper is going to, it was on the assessment and how we develop assessment in the era of AI. And the result were usually in many sessions, this is not a single paper, like different papers, they were focusing on moving from detecting AI work to changing the assignment to be AI resilient. So we need to change the way that we write assignments. If we want the assignment to be AI resilient, then we are not using our old assignments. We need to redesign the assignments. And how is this? Focusing on the correct answer itself is no longer working. We might be grading AI work instead of grading student work. So the move is on discussions, explanations of the answers. If this is a coding or programming course, We may ask students to critique code, find errors in the code rather than writing the code itself. So more emphasis on explanation and justifications of the answer rather than producing the answers themselves. Also, there was a move, if you want to test the student ability to code, these would be in-person assignments or quizzes and exams. Okay, another way of interaction or engagement was those ACM task force sessions or discussion panels. One interesting one that I attended where they discussed what changes education um, with AI, and it was a global session where there were participants from the United States, Brazil, Egypt, and India, and they discussed what changed, different contexts, different countries and regions, but the same issue. Usually the move or we start with changing the assignments. We need to change the assignments or change the way that we assess the students. And I see all the speakers were presenting this first and then how they moved more until we see that in India, they moved from just changing the assignments to changing the whole curriculum. So for each course, they started to write new learning outcomes, taking into consideration the existence of AI and how AI would change the course outcomes, which is a big effort just to change the whole curriculum. So we may start with assessment and assignments, feeding AI in some of the courses, and but we still keep it in mind that this curriculum will change and we need to do changes to the curriculum. Another part and the great part of the conference was the large, spacious gallery room of posters. It was really a big room, and you don't know how to start and where. The sessions were every day. So this gallery opens every day during the conference. I think from Wednesday to Friday. It was open and always busy. Like my camera couldn't take the whole space. It's really a big place. And I had several discussions, one-to-one discussions with the researchers and the presenters. These are part of the pictures that I took with my mobile for some interesting papers. And my focus was on teaching with AI, especially with computer science courses. So the first paper, to tell or to ask, they compared two AI styles. So they designed two systems. One of them generates direct hints to the students when they ask questions, the other with Socratic hints. So with Socratic hints, the AI system will not provide the direct answer immediately. It will make the student think and think. So it encourages student thinking to get the answer. The assumption of the researcher was that this Socratic hints will enhance long-term learning, but their results were the opposite. That was interesting. And digging deep and with the discussions, it's all about how we design the system. There were like some questions about the design of the AI system that was integrated, like lack of context, like they needed to narrow the context from which AI answering the students, which brings me to another research paper where in this research paper, the instructor is in the loop. So with this system, they also integrated AI to give feedback to the students, which is something that we need, especially in large classes. Students seek help from AI because AI is always there. Yes? Anytime the student needs help after midnight, I don't know what time they need this help, they just ask AI and AI provide the answer. If we were able to embed such a tool, an AI tool in our courses, then the students can get this help anytime, like a 24/7 hour TA available to answer their questions. The other system here looks like solving the problem that was in the first poster. And the instructor here is feeding the assignments, solutions to the assignments, and from the instructor knowledge, they know where are misconceptions, where are the common student mistakes, and the instructor also feed the feedback for every common mistake in their answers. The system that they build will combine AI feedback with the instructor feedback. So it's centralized on the pedagogy, and the instructor is in the loop. They got good feedback from testing the system on long-term student learning and having uh, feedback that is tailored and consistent with their work. I attended 2 tutorials, these were from 7 to 10 p.m. One of them was on teaching with AI, where the instructors from Harvard explained how they embed AI in their course, CS50. I will talk about the rubber duck, and Brad will continue from. Are you talking about this, Brad? Yeah, okay. So they gave us a rubber duck, and the idea behind the rubber duck is that if you explain your code over and over to, even if this is to a rubber duck, you will figure out the issue yourself. So they like customize their system in a way that it doesn't give the students answers from the large context of LLMs. It is customized, and Brad will take further about this tutorial. The other tutorial was on multi-tier architectural design of modern systems. The focus, which I loved, and that what encouraged me to attend this tutorial, is how to store data in the cloud rather than storing the data itself in the database. And that is good about those AWS or Amazon Web Services, where we store links to the data, not the data itself in the database. It decouples the data from the system, makes the system easy to expand, more scalable, and of course, it's a cheaper solution, as storing data in the database itself is expensive compared to storing it on the cloud. 2 lovely keynote speakers. The first one was Amy Jo, and her speech was about love, learning, and computing education. Love here is not emotional, is about how much do we care about equity, mental health of the students when we teach. So we need to show love and care for the students when we decide what to teach, how to teach. Are we taken into consideration equity, inclusion of our students with our rigor majors. So it was interesting. She reflected from examples from her own life, and then the rigor curricula of computer science and how we can cope with these issues, and the humanity great aspects when we teach. The closing note was the greatest part of my experience with Dr. Winters on the stage. He was really surprised and happy that he is on that stage after how many years, Brad? Maybe 10 years. He attended the conference and he hoped to be there. And he was so happy being there to doing these great speeches. His talk was really, really great. And he focused on the idea, of teaching the poetry instead of the dictionary. So we don't need to teach the dictionary anyway. We want the students not to write code, but to find the poem in that code. Students should have ability to critique code, correct design issues, rather than writing the code that AI can produce. So everything between quotations here are the statements that Dr. Winter say, and I really like them. So AI doesn't remove the need of computing education. It reveals that we must teach deep skills like design, judgment, and software quality. Am I exceeding my time, Joan? 2 minutes, that's great. Yeah. And that will shift CS education. And I think every education. Like, how are we gonna teach without teaching the code? We will teach the code, but we will put less emphasis on the code compared to other aspects. Like when I heard the talk, I was like, um, are we gonna drop CS0, CS1, start from CS2 or CS3? Okay, no, it's just change the way we teach and how much we emphasize coding with respect to the other things that are needed. Even industry presenters were about this, and they want the students to know how to use AI. So for students to be hired to get jobs or internships, they need to know how to use AI when they program or develop systems. And that is what I said, like, we need to start emphasizing design, debugging, code validation, correction, considering the non-functional aspects. Like, it's easy for AI to satisfy the functionality of the system. But the non-functional aspects like security, maintainability, safety of the system, how easy is it to change the system, the reusability of the components, the usability, this needs the human in the loop. And this should be what we focus more when we teach students. These are my broad takeaways. AI is here, it's not going anywhere, and we need to shift teaching, assessments, and assignments in our curriculum. This would go over time for sure, but we still have challenges. We do not know exactly how we teach with AI. We do not know, our students also do not know how they should learn with AI, and we do not have specific outcomes or competences to know how students master AI so that they get jobs or what is really required by the industry. Thank you all for.
Thank you, Eman. Half of those slides, if you told me those came from an engineering education conference, I would have believed you. We are going through so many of the same challenges right now, and I think we can learn a lot from each other. All right, so now we will pass it over to Brad Barnes. Thank you so much. So that is
I don't know if I'm going to need it.
it'll help with the
Oh, okay. Hey everyone. I'm Brad Barnes. I'm going to do my best not to repeat what Eman just said and offer a different take on things. Hopefully we'll complement each other. I know I submitted my slides, and then afterwards I realized I had no pictures and I had no discussion of the conference. So I appreciate Eman for talking about the conference as a whole and putting nice visuals in her presentation as well. So and I'd like to also thank engineering education for sending us here, and John for all of his hard work. Okay, so the reason I went to SIGCSE, so I haven't been to SIGCSE, and I realized it had been a decade. And when I submitted to go this year, the big thing that I wanted to learn was to understand how other educators are adapting to life with AI. And so I was sitting in the Atlanta airport, like getting ready to get on the plane, and the people behind me were talking about this, right? And like when I mean, I hadn't even left Georgia, right? So everybody was talking about it everywhere. I heard conversations on elevators, dinner tables, like across from me. People are like, "What are you doing, right? How are we coping with AI, and what are we doing to ensure that students are still learning and not bypassing the learning with AI?" So, and the other reason that I go to SIGCSE generally, like this was this year, but generally it's just a great community of people. I mean, you go there and you're like, wow, I'm not the only one going through some of these things. You realize you have other people who are having the exact same experience as you, and it's not something that you're necessarily doing, but it's a nice support group. So, all right, the first talk that I went to was the workshop that Eman mentioned. So I'll go a little bit more in depth about this. So this is a talk from David Milan at Harvard, who teaches CS50. It's a really popular course. I mean, you can take it online, and it's just a nice, broad introduction to computer science. They do it in a really fun way that's accessible to many people. And so what they've done is they built a controlled AI system, as Eman mentioned, that guides students and doesn't give them answers. And so the students are allowed to use this, and they give it system level prompts. So they'll tell the AI, like, hey, you need to act like a rubber ducky, right? And it'll actually, I don't know what that means. Okay, I haven't used it, but I don't know if it makes quacking sounds or something. But yeah, they'll say you need to act like a duck, you need to not give them answers, you need to guide them. And then they've actually tailored these prompts very specifically and tested it to make sure that the AI is doing what they want it to do. So that was interesting, but I think the more interesting thing to me was super technical. They will record every single lecture. They will get the captions with the timestamps, and they'll actually train the AI with these timestamps. And so students can query course-specific information. Like you can say, when did the instructor talk about Super Mario Brothers? And the AI will actually come back and it'll say, David spoke about Mario Brothers on this day. Oh, and here's a link to the YouTube video at the exact moment where he talked about it, right? So they use the example of Mario Brothers because it wasn't course specific, but students could do that with anything they wanted to do in the course. So they've used the AI to actually enable these powerful course specific queries that students can use. So I thought that was really cool. It's a lot of work. They have a team of TAs, and they said it would only cost the students $1 per month with throttling. And that means, like, if the students are really blasting this with queries one after the other, that it'll sort of give them a delay before they can ask another question. But of course, at Harvard, they're working with ChatGPT, they're working with Microsoft. That's all funded for their students, but it's a really cool thing that they're doing, and hopefully in the future, maybe some of the costs will come down and this technology will become more widely available. Okay, so again, I'm just kind of focusing on ways people are using AI. So at Harvard, they have assignments where they make the students teach a concept to the AI, which I thought was really cool. They're like flipping it a little bit. So instead of the AI giving the answers, the students are giving the answers to the AI, and then the students will take this conversation and upload it into their course management system. So I thought that was really cool. And then the TAs grade it. It's graded on participation, right? So they want to see that the students are doing it, they're making an effort, they're showing some knowledge of the concepts, and maybe that sort of thing evolves over time. But one aspect of it that stood out to me is that the AI it's very friendly and it's very forgiving. So if the student says, hey, I don't know, it'll sort of guide them and get them to dig a little bit deeper so that the conversation doesn't just end right there. So that was an interesting use of AI that I saw. And then I also saw schools like Stanford using AI to give feedback. So they have a course with 21,000 students in it. It's an online course, obviously, but I don't know. That's just, I can't even imagine. That's orders of magnitude beyond where I would want to be. But the idea was that they use the AI to reason about student code, provide them with grades, but also provide them with feedback based on their rubric. So I thought that was a cool use of AI. Obviously, what it provides needs to be vetted by a human at the end of the day. But that was a cool use. Okay. Other talks, they recommended frequent in-person assignments is something that they were doing to sort of combat students going home and just using AI to answer all of the questions. UC San Diego was doing weekly 10-minute coding assessments to replace their take-home homework assignments. So they're doing these things in person. They were doing them really quickly, and they were seeing some good results from this type of thing. So just I don't remember the exact details, but I mean, it wasn't pseudocode. They were actually answering the questions, and one of my questions was, is that really enough time? It seemed a little bit short to do a coding assessment. And as I get to the end, I'll tell you what I'm doing currently that I think is kind of working out well for me. Um, but yeah, they were having real coding assignments that they were giving a short amount of time to. All right, so I also went to a talk from Google and heard from, a number of people in the industry, and I took some notes on the industry expectations and maybe how those are changing in the age of AI. So it was clear that employers value AI fluency. They want people to be aware of AI. They want them to be using AI. They want them to be proficient with it, ideally. They want to understand. They want people who understand how to prompt it. And then one quote from the person at Google said that, the real risk is employees with AI training replacing the employees that don't have it, right? So it's not, they didn't see the risk as the jobs going away. They saw the risk as the jobs maybe going away for people who don't know how to use AI. So that was an important point that I noted. Then another thing that came up a few times is that graduates must be able to critique AI output. So as Eman said, this was a pretty big theme at the conference, was that, there's a shift from the students just implementing a solution to the students actually seeing a solution, judging it, saying whether it's efficient, and then sort of zooming out from the specific code and thinking more about the system architecture and how the system is going to be designed. So that was an interesting point that I think we can adjust to and maybe start teaching students some of these higher level skills while they're still in college. Okay, some other notes directly from Google. They are pushing AI use at the company. One, for productivity, but also they want their employees using it so they can make their models better. So that was interesting. And then 80% of the developers there had reported increased productivity. I repeated myself. Sorry about that. That's the thing I already said. And then they also mentioned that the junior developer role is going to have to evolve, because those are the people who are typically implementing solutions, right? They have the specifications, and they're usually writing the code and writing unit tests, and now AI is doing some of that. So that was an open-ended question. They said the junior developer role needs to evolve, but they didn't say how or what exactly that means. I don't think anybody really knows. But they made it a point to say we still need junior developers, because if we don't have junior developers, we're not going to have senior developers. We need somebody to build up. But what does that mean? We'll see. So, all right. And then, as Eman said, we had a fantastic keynote right at the end of the conference that really sort of summarized everything I think that we should be thinking about. AI is definitely reshaping the discipline, and the computational disciplines. I know it's changing things in engineering as well. And the speaker was pointing out that the curriculum has to evolve. I mean, we have to think about how to change things from, let's focus on syntax and tell students where their semicolons need to go, and start focusing more on planning, validation, making sure the code is secure, testing code, and just giving students the skills of looking at code and saying whether it's good. And they should be skeptics. They should use their judgment to pick out the code that really should make it to production. And then he emphasized that teachers need to evaluate the process, not just the product. So as of right now, we have students submit projects, and we grade them on correctness. We run them against a bunch of tests, and they get a grade, right? So they were really questioning that and asking whether that's the outcome that we want. The speaker said, specifically that product-only grading should be phased out. Like, we're not looking just for working code, but we're looking to maybe evaluate how the students approached it. Like, what was their plan? Have them reflect on the code. They wanted to reward test design and maybe efficiency, like, and then an explanation of why it's doing what it needs to be doing. So, and then one of the questions from the audience was like, how do we grade this? You know, if we're taking in plans and then we're taking in reflections about what was done and analysis, how are we going to grade it with, you know, large courses? And I think that's a very good point. I don't know the answer to that. The speaker said, well, the English department's been doing it for forever, so maybe we have to talk to them. I don't know. I don't know what the answer is there, but it's a lot more subjective to grade this type of thing than it is to take up code and run it through unit testing. So I don't know what that means. So some of the discussion questions for faculty that came up, and I think, you know, we can all be thinking about some of these things, whether we're in computer science or other engineering disciplines. You know, one of the questions was, do we let students vibe code for a bit? Let them, you know, maybe in their first semester, do some vibe coding, get some hands-on practice with code, even though they don't fully understand it, and then maybe let that motivate the fundamentals in the later courses. So that was sort of computer science specific, but another question that came up is, what does integrity mean in 2026? So do we want them to use AI, right? Is it okay that they're using AI? If they are using it, have we taught them how to use it? Are they using it properly? Are they still learning? I mean, I think that should be the goal at the end of the day, is that the students are learning something, they're getting skills from this, whatever that looks like. So we need to teach them when to use AI and when not to use AI. And then what evidence of mastery should we require, right? What are we really looking for at the end of the day to say the students have mastered the skills that we want them to master? Okay, so just a quick note about what we are doing now in our course. So in 1302, I teach 2 sections of it. We made a few changes. I feel like they're working out pretty well so far. But we have regular hands-on group activities in class. So every day, I mean, it's active learning embedded into the classroom. I've always done this, but I'm doing a lot more activity discussion, like a back and forth. Whereas in the past, I'd give them more activities for them to do, like longer activities. But I've embedded more discussions this semester than I have in the past. And I think, I mean, I've really good engagement. Students are into it. I can look out at any given moment and they're all doing it, which is a win. And then we're doing 6 smaller mini exams, is what we call them. So instead of 3 big exams, we're doing more frequent check-ins so that the students get more feedback more regularly. So if they're falling behind, they know it sooner and they get that feedback. And then for our projects, we're requiring them to submit plans and come up with unit tests. So, I mean, they've always done that, but we haven't forced them to do it early on and really think about it before they write the code. And we're getting a lot better questions in office hours. Students are coming in with plans about what it is they're going to do, and then they have tests, they have questions about them. We're getting a lot less, you know, I don't know where to start this. We've also lowered the project weights. So the mini exams carry a heavier weight. And then all of our old take-home homework assignments are now the exam review activities. So we give them to them, they can still do them, and we try to pull exam questions from them. So that way they're hopefully motivated to do them, understand them, as opposed to just do them to get the right answer and to get the grade. So just a handful of stuff that we've done. It was nice to see that some of the stuff that we were doing was also some things that came up at the conference that other people were trying as well. So, okay, yeah, that's all I have.
So now what we're going to do is I'm going to ask Brad and Iman to come sit up front and we'll do a question and answer session. It can be for either presenter or for both. Who? Yeah. So when you have a question, please raise your hand and I'll bring you the mic.
Thank you both for sharing your experiences at SIGCSE. Very enlightening. I'm engineering ed, electrical. So unless we collaborate, I probably will never be there. But I'm curious, especially Brad. Okay, Brad. I wanted to make sure. You mentioned how we have to essentially change how we evaluate students or how we teach students, shifting from syntax to more like overall thought, execution. And I guess I'm curious as to why prior to AI there was such an emphasis on syntax as opposed to the like design, algorithm building, debugging to begin with. I guess wanted to know if you had any like insight as to why that was the traditional way that it was being taught, and with the rise of AI, it's like, holy cow, we actually do need to move away from this method.
I mean, I just think we've always taught design for sure, but I think maybe now there's an opportunity to spend less time focusing on the syntax and more time focusing on the design. So I don't. It's not that we didn't do design before. We have design courses for software engineering and things like that. But I think maybe there's an opportunity to sort of look at the design and focus on the design documents and maybe take even a higher level of student have the students engage with the system at a higher level that maybe we'll have time for now that we didn't have time for in the past because we were doing more of the syntactical stuff. Again, that was a suggestion. I think it's a good suggestion. And I think we really have to think about what that means and where it's appropriate in the curriculum. I think students still need fundamental programming syntax. I don't think that's gone. I mean, if we're expecting them to assess code that AI is writing and they've never written any code, that's going to be really hard, right? But I do think there's an opportunity to shift just a little bit more in the design area and give them some of that experience during their undergrad education.
Yeah, Adele.
Okay, so I have a question for Eman. She mentioned the India experience with changing the curriculum and the students' learning outcome. So they are thinking of shortening the period for the whole curriculum or just changing the students' learning outcome? Because I noticed some of the school now thinking about instead of 4 years, they're thinking about 3 years programs for most of the PS.
Is there a question attached to that?
The question?
Yeah.
Yeah, so the India experience, they're thinking shortening the period of the program or just changing the students' learning outcome?
As is, and they are just having meetings between the course coordinators for each and every course so that they change the course learning outcomes and the course design to match AI. But they did not mention that they shorten the list of courses. Was that the only question, or? Yeah. I want to add that I attended another conference in California, which is the Gen AI conference, and I had an experience from another professor from Australia. They also changed the whole CS curriculum. And that did not result in fewer credit hours, but they changed most of the courses. They have some courses who refused to embed AI in the course, and they kept the old courses as is, but most of the courses have embedded AI into them.
I didn't go into that.
Oh.
Yeah, so my question, second question regarding your changes you did in your course. So you mentioned you focus more on the mini exams instead of the projects. So you have 6 mini exams now instead of 3 mini exams, instead of 3 exams. So still you use the whole class time for the exams, because I do the same thing in my course and it's affect my progress in covering the concept, because I use some of the class time for the exams and also for the review. So you use the whole class time for the mini exams or part of the class, and how you deal with the DRC students, because some of the students, they do their exam on the DRC. Yeah.
So the mini exams are 45 minutes, whereas a regular exam in the past would have been an hour 15, whatever the full Tuesday, Thursday time period, 75 minutes. Yeah, that's right. Yeah, we'll call those maxi exams. I don't know. But yeah, so now we give our mini exams we try to do it on the Monday time slot. So we have a Monday, Tuesday, Thursday class. So that's the ideal situation, is we just use a Monday instead of using a longer Tuesday or Thursday. Because of the snow days we had this year and we had another cancellation, we were like a week behind and the schedule's shorter. I don't think I realized that until recently. We just don't have as many days. So there was I think 2 days where we had to have a mini exam on a Tuesday or a Thursday. And I explained to the students that we were still going to do something in the first half, but I was going to try to connect it as much as I could to the exam, so like we're still going to talk, make some progress in the material. But hopefully it'll serve as an exam review in some way. So I did do that. And then, they had the last 45 minutes to do the exam. So you asked another question about the DRC students, and what I did is the students I have that are taking it with the DRC came to the lecture part before the test, and then their start time was a little bit later than the other students to give them time to travel over. Yeah. So it worked out okay. I was concerned about it too, but it worked out just fine. And I think overall it's the same amount of time taken for exams.
I also have more quizzes and exams this semester, like exceeded from 5 to 7. And sometimes I choose to schedule those quizzes or mini exams on Monday, because the Monday lecture is shorter. And even if they have 10 minutes extra, more than the duration of the quiz or the exam, I assign them a video lecture to watch before coming next. And same for the RC, they usually take their tests from 6 to 8 p.m.
Yeah, my exams have never been fully I mean, it's cumulative in the sense that if you don't know the stuff from weeks 1 and 2, you're not going to know the stuff in week 3. Like it's naturally cumulative, right? So I just don't go back and ask them direct questions on the older stuff. But I mean, 1302 is, you better know 1301, because I mean, it's coming up every single day. So it's pretty cumulative just naturally. But yeah, they're not. I struggle with this question when students ask it. Like, is it cumulative? I'm like, yes, but no.
Yeah.
Right? And like, sure. But the exam wouldn't have to be. I mean, we give them an opportunity. So we drop one of them because we have 6. And then we've decided to give an optional final that will adjust the weighting at the end. So if students, like, there's a lot of opportunities for students to, maybe not perform their best and then to still recover as long as they they get the feedback, they take it seriously, and they start working toward that. So, yeah.
Um, Thank you for bringing us this knowledge. And my question for Eman is about one poster that you showed the Socratic tool, and you said the result was the students didn't had the long term learning, something like that. Do you remember or do you have an idea how did they measure this long term learning?
I don't remember exactly, but I think they had quizzes and exams, and those were for this sample that they are testing. The 180 something students took the survey and went through the exam as well. They did not perform well. I don't know if it's related to the sample of students that they took, but according to the presenter, he said that there were issues in the design of the system itself. They need to be more focused to bring context from the course itself. But AI was like adding more stuff, making it easier. I don't know, did I answer your question? A semester, 2 semesters, yeah, 2 semesters, yeah, not 1 semester. So they measured long term as 2 semesters. Yeah. Yeah. I know, like long.
All right, this will be our final question for the session.
So, do you know if India or anybody else who has said that they've changed their curriculum has had time to implement an entire curriculum of 3 or 4 years and then reflect on whether or not it's working? Were they able to say that?
I imagine they'd have to be quite forward thinking to have started it 4 years ago.
That needs a long-term study.
Yeah, I don't think anyone have it like worked for years. They are just doing it now. And I think we are all in the same boat. We don't know what to do, where to start, and we're just trying things to see what will work. Yeah. So both the one that I attended at SIGCSE and at Gen AI, both who presented are still doing this curriculum, and it's a huge work. There was like a large community committee, sorry, working on this, like more than 10 professors just to change the curriculum and coordinate with the instructors of the courses.
I think it's tough right now too because things are changing so quickly. I mean, I think it would be hard to go and change your whole curriculum. I mean, we just don't know where we're going to be in 6 months or a year or 2 years. And there were talks being given at SIGCSE that were almost outdated by the time they gave the talk. Like, I mean, we had people presenting that would say, you know, I did this type of project with my students and I let them use AI, and this was the outcome. Like the AI struggled to do this and this and this, and I'm looking around. I'm like, it's not going to struggle with that anymore. You know, it's there's no way. So it's already changed so much that people who had really nicely implemented projects that worked with AI, you know, last summer, it's like they're already outdated. So I would hesitate to change the entire curriculum right now without knowing where we're headed. So yeah, it was interesting to see that. I've never been to a conference where it's like, oh, that's a really good idea for assignment. Oh wait, it's not anymore. Like it was a good idea for assignment, you know, six months ago, but maybe not now. So
Yeah, AI is like changing more rapid than what we imagine. Like we got used that we learn programming languages and they are no longer used and we have to use a new technology or a new programming language. But this change and enhancements in AI, LLMs, and is really fast and we cannot cope with. I think if there is some serious change to the curriculum, it will come from big organizations like ACM with the new learning outcomes, and at that time we can follow. But now we will think of changing courses, not the whole curriculum.
Thank you. And thank you everyone so much for coming. Let's please be good stewards of the space. If you have